Welcome to this video. In the previous video, we introduced aXis2000 for stick-sum data analysis. We also looked at installation process and how to remove bad lines and bad images if they are present in the stack. Finally, we also looked at how to align images within the stack. I'm going to read my image stack, which was aligned. To read a stack, you use stack analyze, stack process. This is my stack, which is aligned. I don't need to read this file. So by quickly playing the video, you can see there are no bad lines and no bad images. Some users may prefer to work with transmission mode data, and others might prefer to work with optical densities, data that are converted to optical density or absorbance. Remember, in stick-sum, the X-ray interact with the sample, and some of the light will be absorbed by particles in the sample, and the remaining light will pass through the sample and measured by the detector. The measured intensity is what we call I, the transmission intensity. On the other hand, we have I0. The I0 is considered as the maximum transmission intensity, which is considered to be the total incident X-ray that interacts with the sample. To measure it, during sample preparation, you will need to leave an empty area on the silicon nitride or a copper grid so that during the measurement, the light that passes through that empty area will be considered as the I0. These are two values that you need to calculate the optical density from the transmission data. But first of all, we're going to see how to estimate this I0 from your samples if you have it in your image stack. I close this widget. I'm going to open the widget that we used for alignment. It was in stack, Jacobsen analyzer, and I'm going to read my stack which is aligned. To estimate that I0, I press select I0 from histogram, and the pixels that correspond to the maximum transmission intensity, those will be selected by left clicking on the mouse, drag it to the right, and accept as I0 region. So this is the I0, and I need to save I0 spectrum. It will be saved as NEXAFS file. I need to give it a new name. I can press enter. I can also close this widget and back to the main window. During calculations, the I0 should be stored as a text file, and the one that we have is saved as NEXAFS file, so we need to convert it. I will first read it. If I want to be stored in this buffer, I first need to click it. You can click anywhere. Let's say if I need to store, if I need to store my spectrum in the 5th buffer, I need to press there and read it. I go to read function, spectra, NEXAFS file. This is where it's saved, and you see it's already here. So to convert it to a text file, I will use a write function, which helps to store a data into another format. So if I press write, and axis, the window will appear asking me to save it as a text file. I can give it a name. So now I have I0 as a text file. I will also need to read my image stack and from stack analyze stack process here. This part of the widget is the data manipulation window, and the bottom is the output control window. So to convert transmission mode data to optical density, I will first need to load the text file. I will use this tool I0 file and read the text file, and I will press OD, which means that convert transmission images to optical densities using I and I0. If I press here, the data will automatically be transformed into optical densities from transmission mode data. The brighter the sample means there is more absorbance, and the darker means there is less absorbance or more transmission. I need to save this file as well. I will give it a new name. Let's call it optical density. Remember, you always need to press enter and save it. It means that now I have a stack in optical density. The next thing we are going to do is to extract spectra. There are different ways you can use to extract spectra. If you need an average spectrum that covers all pixels in this image, we just go to I all. If you press here, it will show you a spectrum that represents all the pixels in your image stack. This is an average. You can save it. Remember, to save, you need first of all to press enter in the new name. You can rename it, and if you press enter, then this part will be activated and you can save it. Another way, you might need to only choose an area of interest. Maybe you don't need to have a spectrum from the entire sample. So first of all, you need to press a region, I region. There will be a widget here, but it's still not active. The first thing you need to do is to select your region of interest. To select it, you will left click on the mouse, draw a region that you want. So I press left, I draw. When you're done drawing, you should press the right of your mouse. This will allow you to activate this part. You can accept the region or reject. If I press accept, I will have a spectrum that represents pixels in this region. This is an average. You can also choose to save it as well. If I want to save it, I should press here, rename it, let's say region, press enter and save a spectrum. Now I'm sure it's saved there. I can reset. If you only need a pixel, a spectrum that represents a pixel, you simply click pixel and somewhere in the image. The same, you can save it. So image stack, which means that image stack allows you to extract a spectrum either from the entire region or from specific region or specific pixels. In addition, it can also allow you to extract spectrum from thickness. So you can get thickness-based information. How to do that? I can close this. I can read my stack again, OD. In order to have information which is based on thickness, I first need to calculate the average stack. I can store it in buffer number 1. You can choose to save this image, average. I call it average. So this is the average image of all images in a stack. In order to see the optical densities values, and these optical densities, I need to go to the images, generate mask, threshold, histogram. So this widget, this window will show you the optical densities, minimum and maximum. And remember, from the Beer-Lambert's law, optical densities are proportional to the amount of the sample you have, which means that they can be related to the thickness. So from the sample that we have analyzed, it shows that the minimum optical density was 0.48 and maximum value was 2.5. If I want, I can have a spectrum from entire region. What you need to save ROI, region of interest, and save it. Maybe I call it 0.48 up to 2.5. Yes, you can also save mask image if you want. You first need to press there and store it in any of these buffer. I save it to the buffer number 2. In order to save it in your folder, you should click on it and write aXis. If you write aXis, it will be saved as AXB file, which can be read by aXis2000, but also you can read it in GPG, PNG, TIFF if you want to use other software that cannot handle this kind of data. But if I save it as aXis, so it's AXCB, I can call it for instance X. Go back to this. So if you are interested only in the thin region, and remember optical density are related to the thickness, so I can shift the higher maximum to a lower value. Let's say I'm interested to have a spectrum from 0.48 to 1 optical density. In order to shift the maximum, you should press on the right of your mouse. If you press on the left of your mouse, it will not work. That will only shift the minimum. So the left of your mouse shift the minimum, and the right of your mouse will shift the maximum. And you should not type here a number because it will not work. It will give you something else. So if I press right on the mouse, I will be able to move the maximum to 1. So in this case, I'm going to have information from 0.48 to 1. Save ROI 0.48 to 1. You can also, if you're interested, you can also have information from the thicker part. For instance, from 1 OD to 2.5 OD. And in this case, you can also save mask image as we did for the entire image. So let's go to the thick region. Maximum was 2.5, and I want another spectrum that starts from 1 OD. I can save region of interest. Let's call it 1 to 2.5 optical density. So now I have selected or created mask as a region of interest that I can use to have spectrum, an average spectrum that represent the entire region for specific mask. I can close this, and I need to read again my stack as OD file. So here we are. To read, in order to convert the ROI into a text file, I will go here, ROI file. I can read, for instance, the entire region. No, this was the thickest region from 1 to 2.5. And when I have it here, I can press spectrum as a text file. I can reset, read another, the thin one, press spectrum as a text file, reset, ROI. This was the entire region, press spectrum. I can read all these three spectrum. To read, I go to read, spectra, aXis, because I want to read a text file. I can start with the thin one stored in the first buffer. In the second buffer, if I want to store another one, I have to, first of all, to press there and read. This time I read the thicker part. I want to store another spectrum in the third buffer. I should click there and read a spectra aXis. It was this one. So this means that I have three spectra representing different thickness, and these are average spectra for those specific masks that we have created. So in summary, we have seen how you can extract spectra depending on what you want to do. If you are only interested in a specific region, you can immediately find the region you are interested in and use IO region to select. And remember, after selecting, you will click on the right of your mouse in order to have another window activated and accept a spectra. Or you can have thickness-based information by first creating an average, and from the average image stack, you can create masks using this images function, generate mask, and threshold and histogram. So for now, we will end here, and we will continue in the upcoming videos with more about data analysis using aXis2000. I thank you very much for watching this video, and I welcome you to other videos as well that will be uploaded later. Thank you very much.